Hello and welcome to the last of kind of our standard lessons for the semester. So today we are looking at reverse engineering. I know I've already talked about reverse engineering, but we're just covering it in a little bit more depth today. So what is reverse engineering? I mean, it's taking a look at a product that is already developed and then figuring out how it works. Companies use reverse engineering to analyze the functioning and manufacturing of a current product for product improvement or optimization. So let's think about this in terms of first, what is engineering? Engineering is the process of moving from an idea, an abstract idea, to developing the logical designs and the physical implementation or construction of a system. So it's applying the engineering design process. You're going from the idea to a finished product. But what is reverse engineering? Engineering is the process of analyzing an existing product. So you're taking something that already exists to determine its function so that a similar product can be developed or the original product can be improved. Okay, so you're copying a product that exists in some way, shape, or form, or you're going to take that product and then you're going to improve upon it. So why do people reverse engineer products? The original manufacturer of a product no longer exists and or no longer produces the product. So this would be if the example that comes to mind, which isn't entirely accurate, is like when Hostess went bankrupt, and so then Twinkies were no longer being made. Then another company comes in and says, okay, well, we're going to make a Twinkie-like product. That's not entirely accurate because another company just bought the Twinkie recipe, so they didn't exactly reverse engineer, but it kind of fits this mold a little bit. Okay, another reason to reverse engineer a product is that the product has features that are negative and or to improve the product's performance and features. So the example that was very apparent to kind of my generation, we grew up with the original Nintendo Entertainment System. I was pretty young when that first came out, and the controller for the original NES was just a rectangle. It had sharp corners, and if you now you could go from start to finish in an original Nintendo game in less than 30 minutes, easy. But if you played for a game for a while, the controller would hurt your hand because of the sharp corners. And so then the controller, when the Super Nintendo, the SNES came out, then it was the controllers, I think they added a couple of buttons, but also they rounded the corners, and so they improved on the features. And that's actually a special branch of engineering called ergonomics, which is just the making things more comfortable for the user experience. Another reason to reverse engineer a product to update obsolete materials or antiquated manufacturing processes with more current, less expensive technologies. We are seeing this kind of stuff going on today with the processes in and how to check out in a grocery store or a retail store with things like self-checkout. For those of you in my class, you probably have always seen the moving conveyor belt in the grocery stores. But again, when I was younger, it was just a metal sheet, and you would have to kind of push your groceries along. So that was another kind of update of an old product to make it better. Another example, to gain a competitive advantage by understanding how a competitor's product functions and or is produced. This is technology in a nutshell. One of the leading innovators when it comes to computer technologies has been for a very long time Sony. And as soon as Sony comes out with their newest computer trend, then IBM, Hewlett Packard, all of these other companies come out with their versions as well shortly after because they reverse engineered the product. Of course, Apple is now one of the leading technological revolutions, and you just watch Apple, whether it's iPhone, iPad, MacBooks, they'll come out with a new technology, and then within 6 months or so, usually less when it comes to electronics, other companies are going to come out with their kind of knockoff versions as well, and that is all reverse engineering. What does reverse engineering include? It includes identifying and documenting a system's components and then the relationship between them, creating a representation of a system in a conceptual form, or creating a representation of a system in a physical form. Okay, so when we're talking about the steps of reverse engineering, one of the things that you're going to see a lot in this is there's documentation. Okay, first, when you're looking at reverse engineering, predictions based on the research and your knowledge of the product. Product's a music player. Okay, well, you already know a lot about music players. And so based off of what you know, you're going to make predictions about how the product functions and why it was designed. Now, for that phrase, you also kind of have to step outside of what we're used to and what we know, because we think a lot of times we still think pretty basic. Why was something designed? Well, it's to play music, and then it's pretty straightforward. But when you start scaling things up into business to business and international business, government contracts and things like that, the purpose behind a particular item, you need to understand. You need to understand what was going on. There was an instance when an F-117 stealth fighter was ended up crashing in, was it Bosnia, I think, and the U.S. sent special ops and all of these people to retrieve that stealth fighter before anybody else could get their hands on it, because they didn't want anybody else to figure out. Most other countries know what the purpose of that fighter is, but they don't know how it functions, and so the United States wanted to keep that a secret. So when it crashed, the United States did everything they could to very quickly recover it, so that way other countries could not reverse engineer its fighter. When you're looking at the prediction process of reverse engineering, some things to think about, some questions that you might ask yourself or ask your colleagues is, what is the purpose of this product and how does it function? But then also, who is the intended audience? Sometimes these are very well known, sometimes they're not. It just kind of depends on on what you are working with. Observations. Okay, using the systems model, make observations about the various inputs, processes, outputs, and feedback that enable the product to function. Again, other questions are that you may be asking yourself: what are the inputs? What are the processes? What are the outputs of this product? And then how does this product produce feedback? I know we covered what those are very minimally, but I do just want to point out, you can see how this stuff kind of starts to come to play in the future. Next step in reverse engineering is the disassembly of a product. When I've taken apart equipment, it's a lot easier to work with this now. But I take pictures. I take a picture how it looks before I even start, and then after each step, I take a picture. So that way, when I need to reassemble it, all I have to do is just look at the pictures in reverse, and then I can see what I did. And I mean, if you're talking like, I take apart a DVD player. If a screw, if I end up with an extra screw at the end of the day, that's, it'll be okay. Does it still work? But, if you're talking corporate scale or government scale, that kind of stuff, even each individual screw, you're going to take that out. You're going to take a picture. You're going to measure its size. You're going to document all of this kind of stuff. Carefully dissect the product, noting all of the components. Some questions that you may ask: can you develop annotated sketches that include measurements and notes on each of the various components, and can those parts be categorized? Especially when you start talking about systems and their subsystems. Categorization is key. Analyze, carefully document, examine, and analyze each of the subsystems, structural, mechanical, electrical, and determine how do they interact. This electrical component runs to this particular mechanical component, and so then that's how they're going to be related. And so when you start the reassembly process or your own engineering design process, you want to take that kind of thing into consideration. Some sample questions or questions that you might ask yourself are, what are the various subsystems of the product and how do they interact? And what are the parts of the systems and its various subsystems? At this point, it should kind of sound redundant as we kind of start going through some of these questions, because the entire time you're thinking about what is going on, what are the processes, what are the systems, what are the subsystems, how do they all interact? Secondly, we're way past secondly at this point. Next step is that you test. You carefully reassemble the entire product and or one or more of its subsystems to determine how the product functions. So, quick example here: when I got to take apart and work with a drone, one of the motors was not working, and so I reassembled that particular element just to see if that motor, if we had fixed it, so to speak, if we could get that motor working, because it would have been a lot of work to completely reassemble the entire drone, see that the motor still wasn't working, and then disassemble the entire drone again. So sometimes it is certainly advantageous to work with some of your subsystems before a full product reassembly. Questions you can ask yourself: how do the subsystems operate together? When the entire product is reassembled, does the device function? And again, make sure that you record all of your observations. And then finally, your documentation. Each step of the process of reverse engineering should be documented. I said that at the very beginning, several slides ago. So in a way, I kind of think that they should have moved this slide forward, but I don't have that control. This is a PDF, so I can't just move the slide. Otherwise, I would. But every step, and I mean everything that you do, should be documented. There is a scene there was a HBO series called From the Earth to the Moon, where one of the Apollo capsules, I'll just say broke. It didn't work right, and there is a scene where they are taking the capsule apart, and you see the one engineer, he names a particular location and gives the specs on what the screw is, or bolt. It was a bolt, and they go through the books, they look it up, and they say you should be able to unscrew this using however much torque, and then they have a device that measures the torque, and when he gets to the amount they expected, the bolt started coming out of the Apollo capsule. This stuff is documented in extreme detail in corporate world. I'm not saying that you have to do that for a high school class, but this I just wanted to give that as an example on a single bolt on the entire Apollo capsule is a needle in a haystack, and the fact that it is documented in that much detail is the kind of thinking that you have to do whenever you're working with engineering in general or reverse engineering. Document all design goals, constraints, functionality, form, geometry, and materials. Develop schematic diagrams that describe the components and materials, and then finally identify any refinements that might enhance the product's usefulness. In other words, point out, you don't change yet, but point out some areas that you think that you can make it better. So that's it as far as this lesson is concerned, and we are done with the classic lessons. There'll be another video that comes along the way in a short while, explaining the extra credit project that I'm going to allow for you to do. But as far as the traditional notes, that that's going to be the last that we do. We're going to move over into Tinkercad moving forward and just kind of work with that for the rest of the semester, as well as trying to do some built-in review as we go. So I hope that you all enjoyed, and I'll see you in class.